Hello students, in the first lecture of chapter 4th we have studied about the quadratic equation, and this is the second lecture of from chapter 4th, and in this chapter we will discuss about the solution of quadratic equation. Solution of quadratic equations. In this lecture we will do the exercise 4.2. Exercise 4.2. In this lecture we learn how to factorize or how to solve a quadratic equation by factorization method. We have three methods for solving any quadratic equation. First one is a factorization method. First one is a factorization method, and the second one is the completing whole square method. Completing whole square method. And the third one is the quadratic formula. Quadratic formula. In this lecture we will discuss about the factorization method. How we can solve the quadratic equations by the factorization method. Let's see an example. This is the given quadratic equation. Here let this say x square plus 5x plus 6 is equal to 0. This is simply a quadratic equation. What is in this factorization method? How we can implement this? Let's say this. First of all, this is the constant term and this is the leading coefficient. Multiply this constant term by leading coefficient. 6 1 6. We can call this factorization method as the splitting the middle term method also. First of all, we have to split this 5x into two parts such that their product is 6. Now we can write this 5 as 3 plus 2. Here x, take x here, plus 3 plus 2. 3 2 6 and 3 plus 2 5. Here x square and here 6 is equal to 0. You can write this x square as x multiply x, and this is 3x as 3 into x, and 2x is 2 into x, and this is 6 as 2 into 3 is equal to 0. Now take out x common from these two terms. Here x common, here x plus 3. From here 2 is common, here x plus 3 is equal to 0. Now this is x plus 3 here and here also common out. Now x plus 3 here and here x plus 2 is equal to 0. The two numbers, or you can say two terms, the product of two terms here is 0. It is possible only when this or this equal to 0. This is x, either x plus 3 equal to 0 or x plus 2 equal to 0, or both are 0. From here we can find out that this x here plus here minus 3. From here x is equal to minus 2. The value of this x here minus 3 and x here minus 2. The value of this x equal to minus 3 and minus 2 are the solution, or you can say the roots, or you can say solution of the given quadratic equation. And You can understand from here also what are a solution or what are roots. Those values of a variable x which make the equation true, which make this equation true. If we put here x equal to -3, then it will make it equal to 0. It will make it equal to 0. If we put here x is equal to -3 whole square plus 5 into -3 plus 6. This is 3 square 9 minus here 15 and plus here 6. 15 minus 15 equal to 0, which is true. So at this -3 is the root or you can say solution of the given quadratic equation. This is the method of a factorization method, or you can say splitting the middle term method. So we can solve out like this quadratic equation by this method. Let's see one more example. One more example. One more example. Solving the quadratic equation. Solve the quadratic equation. This is x square plus 7x and plus here 10 by factorization method. By factorization method. So is equal to 0. Is equal to 0. This is the given quadratic equation. Now x square plus 7x plus 10 equal to 0. First of all, multiply the constant term into the leading coefficient. Here 10 into 1 here plus 10 plus 10. Now we will split the middle term into two parts as that their sum is 7 and their multiply is 10. Multiply is 10 plus 10 here. Now we can write this as 5 plus 2 plus 5 plus 2 plus 5 plus 2 7 and 5 to the 10. Here x then x, here x then x. Now x square plus 10 equal to 0. From here x is common and here x. Here 2 power 1 outside, then 1 is in the interior. This is here 5 plus. From here 2 is common. So 2 is common. Here x plus 2 5s are 10. 2 5s are 10 equal to 0. Now x plus 5 is common from here. X plus 5 is common and here x plus 2 and here x plus 2 equal to 0. The product of two numbers is equal to 0. It is possible only when either this equal to 0 or this equal to 0. Either x plus 5 is equal to 0 or x plus 2 equal to 0. From here x equal to minus 5 and from here x equal to minus 2. This minus 5 and minus 2, minus 5 and minus 2 are the solutions, or you can say roots of a given quadratic equation. This is the answer. Now if we take another example from a exercise 4.2. This is the exercise 4.2 from a Ncert book. This is the exercise 4.2 Ncert. Now this is the first question, first part from a Ncert book. This is the question that x square solve the quadratic equation by factorization method. X square minus 3x minus 10 equal to 0. This is the first part of a question number first from exercise 4.2. Now this First of all, we will multiply this minus 10 to this 1. The multiply of minus 10 and 1 is minus 10. And now splitting the middle term, split the middle term into two parts such that their product is minus 1. Product is minus 1. First of all, you must remember one point. If the product of the constant term and the leading coefficient is negative, then if we split this minus 3 into two parts, from these two numbers, one is a positive and other is a negative. Must remember this point. One is a positive and other is a negative. Now, and the first one is a smaller and second one is a larger. Smaller and greater number. Now, we split this minus 2 into two parts and their product is a minus 10. We can write as a 5 to the 10. But one is negative and one is positive. If here is negative, then the big number or large number is negative and small is positive. Here minus 5 plus 2 x x. Here x square. Here minus 10 equal to 0. Here minus 5a plus 2 minus 3 and minus 5a into plus 2 equal to minus 10 10. You use must in this select such a pair of two numbers that their sum is minus 3 and their product is minus 10. Now from x is common. From here x is common. Here x minus 5. From here you can write 10 as a 2 into 5. From here 2 is common. From here this is here x minus 5. Here x minus 5 equal to 0. X minus 5 here and x minus 5 here also. Taking out a common. X minus 5 here x plus 2 is equal to 0. The product of two numbers is equal to 0. So you can write that this is either x minus 5 equal to 0 or x plus 2 equal to 0. From here x equal to 5 and from here x equal to minus 2. This is 5 and minus 2. 5 and minus 2 are the solutions or you can say roots of a given a quadratic equation. That's all. Next question. This is the second part from this 4.2 number. First second part here. This is 2x square plus x minus 6 equal to 0. 2x square plus x minus 6 is equal to 0. Now 6 2 the 12 minus 12 here minus 6 into 2 minus 12. Now splitting the middle term into two parts so that their sum is a plus 1 and the product is a minus 12, and you can write this as a 4x minus 3x here plus 4 minus 3 plus 4 minus 3 plus 1 and plus 4 into minus 3 minus 12. Here 2x square minus 6 equal to 0. Now taking out this 2x is common from here and here x plus 2. Here minus 3 is common. Here x plus 2 is equal to 0. X plus 2 common out. Here 2x minus 3 is equal to 0. The product of two numbers is equal to 0. So x plus 2 equal to 0 and 2x minus 3 equal to 0. From here x equal to minus 2 and from here x equal to 3 by 2. Minus here plus 3 by 2. This minus 2 and 3 by 2 are the roots or you can say solution of the given quadratic equation. Now let's see the one more example. This is the third part from a question number first exercise 4.2. Third part, this is the third part. Root 2x square plus 7x plus 5 root 2 is equal to 0. 5 root 2 is equal to 0. Multiplying this, the constant term, this is the leading coefficient. If we multiply this by this, root 2 into root 2, 2 to 5 are 10. Multiply here is 10. We will split the middle term into two parts, that there is sum is 7 and there is product is plus 10. Or you can write this is 7 as x as 2x plus 5x, 2x plus 2 plus 5 plus 7 and plus 2 into plus 5 plus 10 plus 10, x here x. Root 2x square plus 5 root 2 is equal to 0. You can write this 2 as root 2 into root 2 x plus this is 5x plus 5 root 2 equal to 0, and here is root 2x square. Now root 2 here and here also, and this is x here and here also. Now taking out a root 2x common from here, the value of here x, and from here is root 2, here is root 2. This is 5 is common from here, 5 is common, here x plus root 2 is equal to 0. Now taking out x plus root 2 common from here, x plus root 2, and here root 2x plus 5 is equal to 0. The product of two numbers is equal to 0. So you can say either this equal to 0 or this equal to 0. Either this is x plus root 2 equal to 0, or this is root 2x plus 5 is equal to 0. From here x equal to minus root 2, and from here x equal to minus 5 by root 2. This and this, these are the roots, or you can say solution of the given quadratic equation. This is the root 2 minus root 2, this minus root 2, and here is the minus 5 by root 2, minus 5 by root 2. Now let's see the next question, or you can say more example from this factorization method. How we can solve the different type of quadratic equation by the factorization method. This is a fourth example, fourth part, question number first exercise 4.2. This is 2x square minus x plus 1 by 8 equal to 0. First of all, take LCM. Here the LCM is 8. This is 1 8 to here is 16 x square minus 8x plus 1 is equal to 0. Divide here, multiply. Here is 16 x square minus 8x plus 1 is equal to 0. This 8 divide here, multiply, 8 gives 0. Multiplying this 1 into 16 plus 16 plus 16, splitting the middle term into two parts, so that the sum is minus 80 and their product is plus 16. You can write this as a minus 4x minus 4x, minus 4 minus 4a minus 8a minus 4 into minus 4a plus 16. Now you can write here this is x is 16 x square plus 1 equal to 0. From here the 4x is common, 4 4 16, here x, here 1. From here minus 1 is common, here 4x minus 1 equal to 0. 4x minus 1 is common from here, and this is 4x minus 1 common from here, and here is 4x minus 1. Here is 4x minus 1 equal to 0. The product of a two numbers, the product of two numbers is equal to 0. You can write this either 4x minus 1 equal to 0 or a 4x minus 1 equal to 0. From here x equal to 1 by 4a, and from here x equal to 1 by 4. This is the root or you can say solution of the given quadratic equation. Let's see one more example. This is the fifth part from question number first of question number first exercise 4.2. Fifth part. This is 100 x square minus 20x plus 1 is equal to 0. This is the given quadratic equation. We have to solve this by the using of a factorization method, or you can say the splitting the middle term method. Now 100 ones are 100, multiply here is 100. We will split the minus 20 into two part, so that their product is 100 plus 100, or you can write this as a 10x minus 10x, minus 10 minus 10 minus 20, and minus 10 into minus 10 plus 100 here 100 x square plus 1 is equal to 0. From here 10x common, here 10 tens are 100, 10x minus 1, from here minus 1 common, here 10x minus 1. If we take negative from here, the sign will change. Now 10x minus 1 common out 10x minus 1, here 10x minus 1 is equal to 0. The product of two numbers equal to 0, either this equal to 0, either 10x minus 1 equal to 0 or 10x minus 1 equal to 0. From here x equal to 1 by 10, and from here x equal to 1 by 10 also. This is the answer. Next question. This is the question number second. Exercise 4.2. Question number second. Here solve the problem given in example 1. In the example 1 there is a problem. Let this question here. John and Jivanti is the John and Jivanti together have 45 marbles. Together have 45 marbles. Both of them lost. Both of them lost 5 marbles. Both of them lost 5 marbles. 5 marbles. The product of the number of marbles, they now have. They now have 124. Now we will we have to find out a now we have to find out a how many marbles है they had to start with This is the question है John and Jivanti together have 45 marbles है both of them lost 5 marbles है while playing and the product of the number of marbles now they now have 124. We have to find out how many marbles they had to start with. We have to find out how many marbles they had to start with. First of all, let us assume that let John have X marbles. John have X marbles. If John have X marbles, then here John and Jivanti together have 45 marbles. Then Jivanti have number of marbles Jivanti have. You can write here as a number of marbles. Let a number of marbles. Number of marbles in starting John have bx. Now number of marbles in starting the Jivanti have b 45 minus x 45 minus x marbles here. Now according to question each this John and Jivanti each lost 5 marbles. Each lost 5 marbles. Now number of marbles John have. Now number of marbles John have is equal to here x 5 lost of x minus 5 marbles. Number of marbles Jivanti have here in starting 45 minus x 5 lost, so 45 minus x minus 5 is equal to 40 minus x marbles. According to question the product now the product of the number of marbles they now have the product of this and this x minus 5 and 40 minus x is equal to 124 multiplying this is x into 40 x into x minus x square minus 200 minus plus 5x is equal to 124. This minus here plus. You can write this as a here this minus here plus so x square plus this 40 plus 5 45x plus here minus 45x and this minus here plus this is 324 equal to 0. Now this is the quadratic equation. We have to factorize it to solve the quadratic equation. This is x square minus 45x plus 324 equal to 0. And the product of this is 3 to 4 and this one is 3 to 4. 324. This is 3 to 4. 2 1 are 2, 6 are 2, 2 are 4. 2 say 2, 8 are 2, 1 are 3, 2 are 7 are 3, 9 are and 3 3 are and 3 1 are. Now multiply this. 2 are 4, 3 are 12, 3 are 36, 36. 3 are 9, 36 and 9. 36 plus 9 is 45 and the product of 36 and 39 is 324. We can split it as minus 36 minus 36x minus 9x here x square plus 324 equal to 0. For 324 equal to 0. From here x is common, from here minus 9 is common. Here x common, here x minus 36. From here minus 9 is common, here x minus 36 equal to 0. X minus 36 common, here x minus 9 equal to 0. The product of two numbers equal to 0, either x minus 36 equal to 0 or x minus 9 equal to 0. From here x equal to 36 and here x equal to 9. X equal to 9. If zone have it may be 36 here. If zone have 36 marbles, then Jivanti have a 30 45 minus 36 equal to 9 marbles. And if a zone have 9 marbles in starting then Jivanti have 36. Both are the correct answer. Now let's see another example is the question number 3 exercise 4.2. Question number 3 exercise 4.2. Let's see the question number 3. The statement is find two numbers. Find two numbers whose sum is 27. Whose sum is 27 and product is 182. This is the question. Find two numbers whose sum is 27 and the product is 182. Let one number be let one number be x. If one number be x, here the sum of two numbers 27, then if one is x, then other number is, let's see an example. If the sum of two numbers is 10, if one number is 2, then other number is 10 minus 2, 8. 10 minus 2, 8. 8 plus 2, 10 here. If one number is 2, then other is 8. How we can find this? We can find this 8 as 10 minus 2. If one number is x, then other number b. The sum is 27, then 27 minus x. 27 minus x. According to question, the product of and the two numbers is 182. The product of this and this, x into 27 minus x is equal to 182. Multiplying here, 27x minus x square is is equal to 182 minus here plus, or you can write this as a x square plus here minus 27x plus a 182 equal to 0. Now we can solve this by easily by factorization method, splitting the middle term so that the product is a 182, splitting this a 1 to this 2 9s are 2 1s are, and this a 7 13, 7 2s are 14 and 13 their sum is 27 and the product is a 182. You can write minus 27 as a minus 13x minus 14x, here a x square plus a 182 equal to 0. You can write this as a 13 into 14 plus minus 14x minus a 13x, here a x square x 13. You can write this from here 13 sorry, only x is common from here, and from here minus 14 is common, x into x minus 13, from here minus 14 is common, x minus 13 here is equal to 0. X minus 13 common from here, and this is x minus 13 common, and here x minus 14 equal to 0. The product of two numbers equal to 0 you can write as this is x minus 13 equal to 0, or you can say x minus 14 equal to 0. Here from here x equal to 13 and x equal to 14. If one number is a 13, then other number will be 27 minus x, 27 minus 13 means 14. This is the answer. Or you can write as if one number is 14, then other will be 27 minus 14 means 13. This is the answer. Now let's see the one more question. This is the question number 4th exercise. This is 4.2. Question number 4th. Is the question number 4th. Fourth question. Find two consecutively positive integers. Find two consecutive positive integers sum of a Fuzzy square is a 300 square, so Fuzzy square is a 365. Solution. Let us say assume that two numbers or let us say you can write as two consecutive numbers be as x and x plus 1. Let two consecutive numbers be. Let's see an example. If one number is 7, the next number is 8. These are two consecutive positive integers, 7 and 8. One number is 11, the next number is 12. They are consecutive positive integers. If one number is the 7, then next number is 7 plus 1 or not? Yes, these are 7 plus 1. If one number is 11, then next number is 11 plus 1. If one number be x, then next number will be x plus 1. These are two consecutive positive integers. According to question, the sum of Fuzzy square. According to question, the sum of Fuzzy square. Here x square and x plus 1 whole square. The sum of whose square and then a sum is equal to 365 x square a plus b whole square, it is a square plus 2ab 2x plus 1 is equal to 365. Here int a plus b whole square, a square plus 2ab plus b square, 1 square here 1. Now this is 1 and 1 2x square plus 2x plus here minus a, this is minus 365 and plus 1 minus 364 equal to 0. Now dividing by 2 on both side here x square plus x minus 182 equal to 0, 182 equal to 0. Multiplying this minus 182 into 1 here minus 182, splitting the middle term into two parts that their sum is 1 and their product is this. Let's see, this is 2 9s are 2 1s are, and now this is 7 7 here 13 and 13 1s are 13, 7 2s are 14 and 13, 14 and 13, 14 minus 13 is 1 and their multiply is 182 negative here plus 14x minus 13x minus 182 equal to 0, here x square. From here x is common, from here x is common, x is common here x plus 14. From here minus 13 is common, minus 13 is common, here x plus 14 equal to 0, sign change, minus plus here. Now this is x plus 14 from here common, x plus 14 common, here x minus 13 equal to 0. The product of two numbers equal to 0, or you can write this either this equal to 0 or this equal to 0, either x plus 14 equal to 0, here x minus 13 equal to 0, here x minus x is equal to 13 and here x equal to minus 14. This x is two consecutive positive integer, positive integer. These are two consecutive positive integers. This minus 4 is not the positive integer, it is negative integer. This neglecting this, x is equal to 13. If this one number is 13, then now other number is 14. 13 plus 1 14. So two required numbers are two required numbers are one is 13 and other is 14. Next is 14, 13 and 14. This is the answer. Next question. This is the question number 50 from exercise 4.2. Question number 5th. Let's see the statement of question number 5th. This is the statement of question number 5th. Question number 5th. In this question, the altitude. In this question, the altitude of a right triangle. Altitude of a right triangle is 7 centimeter less than its base. If the hypotenuse is If the hypotenuse is 13 centimeter, find the other two sides. Find the other two sides. two sides. Now solution. The altitude of a right triangle is 7 centimeter less than its base. This is a right angle triangle. This is a right angle triangle. Let this point is A, this B, and this C. Right angle. This perpendicular, this base, and this is hypotenuse. The hypotenuse is given here 13 centimeter. 13 centimeter. But from this base and this perpendicular, the altitude means perpendicular height. This perpendicular height AB. The altitude of a right triangle is 7 centimeter less. This is 7 centimeter less from than this. Let this be x. Let this base be x. If this x, then this altitude is equal to 7 centimeter less. We can write this as x minus 7 centimeter. Let base be x centimeter. Base be x centimeter. Then according to question, altitude is equal to x minus 7 centimeter. X minus 7 centimeter. Hypotenuse is given here. Now in a triangle, in figure you can write this A, B, C by PGT, by Pythagoras theorem, by PGT. This is hypotenuse whole square equal to perpendicular square plus base square. Here hypotenuse is 13 whole square. Perpendicular here is x minus 7 whole square, and base here is x square. A minus b whole square, and is a square minus 2ab. 2 sevens are 14x plus b square. 7 square 49 plus x square equal to 13 square 169. Now x plus x 2x square. This is 2x square. Here minus 14x plus here minus. This is minus 169 plus 49 minus 120. This minus 120 equal to 0. Dividing by 2 on both sides. Here x square minus 7x minus 60 equal to 0. Factorizing this. This minus 12x plus 5x minus 60 equal to 0. Here x square. The multiply is minus 60 ones are minus 60. We split this 7 into minus 7 into 2 parts, so that their sum is minus 7 and product is a minus 60. From here x is common. X minus 12. From here 5 is common. 5 into x minus 12 is equal to 0. X minus 12 is common from here, and here is x plus 5 is equal to 0. The product of two numbers is equal to 0. Either this equal to 0 or you can say this equal to 0. This is x minus 5. X minus 5 equal to 0 or x minus 12 equal to 0 or x plus 5 equal to 0. From here x equal to 12 and from here x equal to minus 5. This length can't be negative. So neglecting this, x is equal to 12. The base is 12. Now this altitude, this perpendicular, you can say perpendicular is 12 minus 7 equal to 5 centimeter. Now you can write this as the altitude, base here is 12 centimeter and altitude is equal to this x minus 7. X minus 7 means 12 minus 7 equal to 5 centimeter. This is the answer. Let's see the last question from this exercise. This is the very simple and very important question also. This is the question number 6th. Let's see question number 6th. The statement of question number 6th is a cottage industry. A cottage industry a cottage industry produces a certain number of pottery articles. Certain number of pottery articles in a day. It was observed that on a particular day, on a particular day, it was observed on a particular day that the cost of a production of each article in rupees was three more than twice the number of articles produced on that day. If the total cost of production if the total cost of production on that day was rupees 90. Find the number of articles produced and the cost of each article. Find the number of articles produced and cost of each article. Let's see the solution of this question. First of all, this is a cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article in rupees was 3 more. This is the main point. 3 more. Number of cost of production of each article was 3 more than the number of article produced on that day. If the cost of production on that day was rupees 90, then find the number of article produced on that day and the cost of each article. Let us assume that number of article produced on a particular day on a particular day, on a that day, or you can say particular day, is equal to let x, number of article be x. According to question the cost of production of each article, means a cost of one article is was 3 more than the twice the number of article, twice the number of article, 3 more than the twice the number of article. Then the cost of each article, cost of each article is equal to twice the number of article here x, it's twice, 3 more than plus 3. This is the cost of each article in a rupees, Now if there are a x article and the cost of each article is rupees 2x plus 3, then a number of the cost of total cost of article, total cost of production, total cost of production is equal to this, multiply this, x into 2x plus 3 rupees, and this total cost is given, that is 90. This x into 2x plus 3 is equal to 90 rupees. Multiplying here, this is 2x square plus 3x plus here minus 90 equal to 0. This is the quadratic equation. Now we will solve this quadratic equation. 2x square plus 3x minus 90 equal to 0. The product is minus 180. Split this 3x into 2 part such that their sum is 3 and their product is minus 80. 180. This 290, 245. Now this is 315. 6 to the 12. 15 minus 12 is 3. And 15 into 12, 120. 180, sorry. You can write this as 15x minus 12x minus 90. Here 2x square equal to 0. From here x is common. Here 2x square plus 15. Here minus 6 common. Minus 6 is common here. Here 2x plus 15 equal to 0. 2x plus 15 common. 2x plus 15 here only 2x only here. 2x plus 15 here x minus 6 is equal to 0. The product of two numbers is equal to 0. You can write this equal to 0 or this equal to 0. From here if 2x plus 15 equal to 0, here x minus 6 equal to 0. From here x equal to minus 15 by 2. From here x equal to 6. And this x is the number of article. And number of article can't be in a fraction or in a negative. So neglecting this. So x is equal to 6. This is the total number of article produced on that day. And the cost of each article. Is equal to, cost is 2x plus 3, 2 into x plus 3, 2 into x is 60 plus 3, 12 plus 3 here 15 rupees. 15 is the cost of each article, and there are totally 6 articles. So thank you class. This is the exercise 4.2 completed here. Now we will see you in the next lecture. It is a lecture number 3.